I've heard students say that problems related to trains moving in same or opposite direction, as well as problems related to upstream and downstream are a bit complicated. Realizing this, in this video, we are going to understand the logic behind word problems related to upstream and downstream. Let's start with a clip. Here you see that a lady is rowing a boat in still water. The distance traveled by her will depend upon just the speed of the boat, assuming that she moves straight ahead. I'm going to show you all a clip to get clarity on word problems related to upstream and downstream. In order to understand the concept better, please listen to the sound of the engine of the motorboat. This will help you to realize the amount of power that is being applied to move ahead. Also, if you look at the mountain along with the motorboat, you will realize how fast or slow the boat is moving. Let's start. In this clip, you see the motorboat moving up the stream. Listen to the sound very carefully. You'll realize that it's applying lots of power to move ahead. If you look at the background, the mountain, you'll realize that even though it is applying lots of power, still the speed which it should generate it is unable to do. The question is, will the boat be able to still go ahead? What will happen if the speed of the boat is less than the speed of the river? Let's check it out. As the speed of the boat becomes less than the speed of the stream or the river, it is unable to move ahead. Let's see once again what happens when they apply more power or more force in order to move upstream. Once again, here you can feel the sound of the motorboat roaring ahead. Look at the background. Well, it is coming at a faster pace because more power has been applied in this case. Let's see whether it'll be able to manage it or not. Yes, this time it succeeds in moving ahead. This is because this time the speed of the motorboat was more than the speed of the river, and so it was able to move ahead. Now we are going to see how the boat travels down the stream. You can easily see that it is traveling very smoothly. Even if it is applying less power, still it is flowing down without any problem. The speed here depends upon the speed of the river as well as the speed of the boat. So now we have seen both the clips. I'm sure that you must be able to visualize what happens when a boat is moving upstream and what happens when the boat is moving downstream. So let's take a question. Ritu can row downstream 20 km in 2 hours and upstream 4 km in 2 hours. Find her speed in still water and the speed of the current. Well, before we start solving this question, I would like to analyze. We should analyze the question first. Since Ritu was able to row the boat upstream, it clearly means that the speed of the boat, which we are going to take it as x, will be greater than the speed of the current, that is pond. Secondly, since this is a case of relative speed, so while solving the sum, we have to consider the speed upstream and speed downstream, not the individual speeds. Point number 3 to be considered, and that should be kept in mind. It should be always there. In certain cases, the time may be given in minutes as well, and the speed could be in kilometer per hour. Now, what should be done? Simple. Either convert the speed given in kilometer per hour to meter per second, or convert the time given in minutes to hours, whichever you feel convenient. So let's start solving the question. Obviously, the first few lines would be, let the speed of the boat in still water is equal to x kilometer per hour, and the speed of the current is equal to y kilometer per hour. Speed downstream, obviously, it will be more. So we have to add it up. X plus y kilometer per hour. Speed upstream is equal to x minus y kilometer per hour. Here we are going to take the formula for time taken. Time taken, as you know, is distance divided by speed. So in the first case, that is in case of downstream, 2 hours have been taken to travel 20 kilometers, so it will be 2 is equal to 20 upon x plus y. And if we simplify this, we'll get the first equation, which is x plus y is equal to 10. Considering the second case as the case of moving upstream, again 2 hours was required to travel a distance of 4 kilometers. So the equation we are going to start framing is 2 is equal to 4 divided by the speed downstream, x minus y. X minus y is equal to 2. So this would be your equation number 2. Now the final part would be to solve it out. Adding equation number 1 and 2, you get 2x is equal to 12 and x is equal to 6. Put the value of x in equation 1, you get x 6 plus y is equal to 10, y is equal to 4. Finally, your final statement would be, thus the speed of the boat in still water is equal to 6 km per hour and the speed of the stream is equal to 4 km per hour. I hope you have understood the concept of upstream and downstream. Just remember the video and the solution, the analysis part. Go ahead. Try to solve more problems yourself. If still you find any difficulty, please get back to me by writing a comment. In the next video, we'll be discussing about the trains, as you said. Bye bye. See you then.